12.1 Day 2, Example 1, letter D. We have the limit as x approaches 3 of our function. Because x is approaching a number, 3, and not infinity or negative infinity, we're going to build our table with 7 values in it. And again, we need to do the right and the left hand limit. We don't have a little plus or minus here, so we need to do both sides and then compare them to see what the overall limit might be. The number here in the middle, this number here with our limit, x is approaching 3, that does go in the middle of our x values, and then again adding 0.001, 0.01, and 0.1, and then subtracting those same values will give us the rest of the table. When you're doing these overall limits, again, you don't need to calculate this y value here for our middle number. To determine if the limit exists, we have to look at what happens on both sides, but not at the actual number itself. So you could fill this number in, but it's not necessary. From there, I would want to go through and throw this into our calculator and see what we get for those y values. Our function is x over the quantity x minus 3 squared, x on the top, and then divided by, just like it is written there with the parentheses, x minus 3 in parentheses squared. From there, we want to go to our table. I have some old values here from an old problem. Let me delete those out and then type in our new values. So there are the 6 values we will need for our table. Let me get those written in here. For this value here, what it says on the calculator is 3e6. It's like we talked about in an earlier lesson. That e is really the times 10 in scientific notation, so 3 times 10 to the 6th power, or if we move the decimal over 6 places, the number that needs to go in this blank is actually 3 million. I'm going to do 3 times 10 to the 6th. You could also write 3 million. You shouldn't write 3e6 in there. On the other end, we have 3e6 again here, so 3 times 10 to the 6th power again for that box. So those are the different y values that we get for our table. So what we want to do is take a look at the limit of this left-hand side. That would be the limit as x approaches 3 from numbers that are a little bit smaller than 3 of our original function. And as our x's get close to 3 from the numbers that are a little smaller than 3, our y values go from 290 to almost 30,000 to 3 million. These numbers are getting bigger, and they're getting bigger by bigger and bigger amounts. It's growing very quickly. So it looks to me like these numbers are going to keep growing, and the closer we get to an x coordinate of 3, the higher the y coordinate is going to be. Similarly, over on the right side, we would have the limit as x approaches 3 of numbers that are a little bit bigger than 3 for our function. So looking at what happens to these x values as you get closer to 3, the y values again are starting relatively small, 310, then up to 30,000, then up to 3 million again. So again, these values, as we get closer and closer and closer to the middle, our y coordinates are getting bigger and bigger and bigger and bigger in a positive direction. So it looks like to me, if I were to estimate where the left and right hand limits go, both of the y values appear to be going to infinity. Because those values are the same, or approximately the same, in this case they are exactly the same, the overall limit, which we were asked to calculate, of our original function is going to be infinity. In problems like this, if both of your values go to either positive infinity or negative infinity, then that would be your answer for the overall limit. So if both are positive infinity for the left-hand and the right-hand side, your answer for the overall limit is also positive infinity. If both of these were negative infinity, then our answer here would be negative infinity. If you have one of each, one is positive and one is negative, then the limit would not exist. On all of these problems that I've been working on, I haven't been looking at the graph, but we certainly can go back and take a look at the graph on these. It isn't necessary. They didn't tell us to do that in the problem like they did earlier on the day 1 assignment, but we certainly could take a look. If I take a look at our graph on the calculator, we end up with that graph right there. Let me go through and zoom in a little bit so you can see that a little bit better. I'm going to change the window. And since we're looking at a graph that's in the first quadrant, I kind of want to see what's happening there, I'm going to get rid of kind of the second and third quadrants here. So from left to right, instead of going from -10 to 10, I'm going to go from -1 to 10. And then the same thing with our y values. I'm going to go from -1 to 10. So we're mainly focused in that first quadrant where both x and y are positive. So you can still see our origin, that's here. And if you take a look at our x values, when x is 3, it looks like the left side and the right side are both going upward to positive infinity. So that does make sense that we would have an answer of infinity for this problem. The graph again kind of verifies this estimate. It verifies our conjecture.